before we get there, let's go ahead and set up the agenda for today's meeting. I'm going to click through to the next screen. We're going to some of you may or may not. Some of you may be familiar with Wellntel. Most of you, I think, are not. So what we'll do is spend just a few minutes on a summary of the equipment, how it can be used, and then we'll talk about setting up a test in which we're evaluating or looking for and identifying and potentially quantifying connections between ground and surface water bodies using these equipment. We will actually have a live demo ongoing. We have a system here in our wet lab here in Milwaukee, Wisconsin, that will turn on, and you'll likely hear it happening, and you'll see it happening in real time as data is gathered from that system. And then we'll spend finally some discussion time on tools to find correlations or connections between ground and surface water level that may be available to you once data is collected or as data is being collected. So that'll be our agenda Q&A towards the end. And thank you so much for joining. So to kick this off, let's talk a little bit about the equipment itself. Wellntel launched at the beginning of 2015, January 2015 commercially, though we had been in development and in pilot programs in California and alongside major universities for a number of years prior to that. But basically what Wellntel is it's a groundwater level sensor affixed to the top of any domestic small farm or monitoring well. It's a non-invasive sensor, meaning it doesn't touch water. It's easily installed, and it has essentially built-in telemetry. It communicates via existing internet or existing nearby internet via radio transmission through a gateway and gets data to the cloud. It's designed to measure groundwater level and basically any of those wells I named, domestic, small ag, or monitoring, whether they are pumping wells or not. And it gathers information. Well, we'll give you more information about the type of data it gathers if we move a little bit deeper into the technology itself. Here I have pictured a Wellntel kit that happens to be powered by solar. On the left-hand side of this image is the gateway connected to internet. In the middle of the image is the sensor connected, in this case, to a well seal. It also might be connected to an access port on a turtle cap or a monitoring station, a piezometer style well. And in this case, it's powered by a solar panel that's placed nearby and a little controller and a battery in that black box. It might also be powered by its own internal battery that can be placed inside the sensor itself and powers a system with with a decent number of readings for up to a year, depending on how on what time intervals are set. This system is designed to track groundwater level on a programmable time interval anywhere from 1 minute to 1 week, and that's something that users can program. It will measure drawdown while pumping. Maybe more important than just simply measuring drawdown, it's tagging pump-influenced measurements and applying metadata to those measurements so that they can be included or excluded appropriate to a groundwater model. But because it's doing that tagging, that means we can also isolate and track the amount of time that a pump runs in a well, or conversely, the amount of time that a pump doesn't run. And we can track recovery period, that is, how long it takes for the well to recover after drawdown from pumping. And on all those essentially metrics or data type levels, we can program and send alerts from this system. However, that was all about groundwater, right? And this conversation is about surface water as well. So coupled with a Wellntel on a groundwater well in a nearby reservoir or surface water body, we might add a Wellntel tank system. This is a sensor. Frankly, it's the same sensor with a slightly different set of programmings. In this case, what we've done is we've we've created an alternative mounting method to attach this type of sensor to a sounding tube in a stilling well or a holding tank or a reservoir of or a cistern. In our case, we're going to talk specifically about um, attaching this system to a stilling well on either a pond or potentially a stream. And when that's done, we're in a position to track in that reservoir again on the same programmable time interval from a minute to a week and send alerts, either full or empty or some distance away from full or empty in that reservoir. And when you combine these two technologies, the Plus Pump Kit, which is designed for pump evaluation inside potentially a domestic well as an example, and you combine a Wellntel tank on a stilling well, and you push data to cloud through that gateway or two gateways if you want to speed the process through nearby internet, what you end up with is data that, of course, can combine groundwater demand to surface water conditions, or groundwater supply on the other side to surface water conditions, and maybe even get down to a point where we can see whether or not local pumping inside a well is having an impact on surface water nearby. So as just a quick case example, there are Wellntel systems in local networks in two large pieces of managed land along Highway 1 along Central Coast, California. These are areas where streams exiting into the Pacific Ocean are spawning grounds for fish, but they're also areas where there is necessary pumping for irrigation reasons to be able to grow crops in the valleys. And so an opportunity in both of these managed land areas is to place Wellntel on stilling wells in streams and Wellntel on groundwater wells feeding crops, and tie the data together to know whether or not the stream is being impacted by the pumping at, for example, spawning times, which might have an impact on fish species. So this, when combined, is an opportunity to create a long-term ground to surface water study with some data opportunities that are, we think, unmatched. I'm going to jump right into demonstrating how this might work in an idealized lab environment. And let me first tell you that this lab environment works exactly backwards from what you might expect to have happen in the field, and I'll show you why. On the left-hand side, what you're looking at, and frankly, I'm looking at this too because it's right across from my desk. You're looking at 3 barrels, 2 filled with water. The one on the left-hand side represents our surface water reservoir. It's higher than the groundwater gravitationally in elevation, obviously. And atop that surface water tank is the surface sensor. That is a Wellntel tank powered up and ready to measure the water inside that tank. You'll notice a transparent small-scale food-grade hose with a valve on it that is essentially representing gravity, and that would mean recharge from the surface water tank to the groundwater tank. So on the right-hand side of this left-hand picture, the lower tank on the right is representative of our groundwater condition. It is simply an open tank. It isn't truly groundwater, right? It's a directly coupled system where the surface water drains to the groundwater. There is no sand here, so it's not slowed by a percolating effect. The only way we can slow this, frankly, is to reduce the diameter of the valve, and we can do that. You can see in this image a pump atop the groundwater tank, and what we'll be doing momentarily is pumping up into the surface water tank. If you look to the image on the far right, however, what you'll see is that at the other end of this groundwater system is a Wellntel sensor atop what we're calling an artificial well. So this well, in fact, it makes 2 turns, 2 90-degree turns, in order to allow us to have this thing in a place with a roof that's only 10 feet high or 11 feet high. but it's indeed a 38-foot or so groundwater well. And so we're measuring from both systems. In the middle image is an up close of the groundwater sensor. What this lab test allows us to do is essentially see a direct hydrologic connection between these two tanks. And so there are a number of analytical opportunities just revealed by this concept. And the first is we could measure groundwater decline versus surface water decline. We can measure well, let me continue. We can also measure groundwater pumping versus surface water change. It might be, however, in this case, and here's how it's directly backwards, groundwater pumping is heading right into our reservoir. So the change is going to be an increase in water level in the tank as opposed to a decrease, which is what we might see if we were naturally coupled in the real world. We can measure pump time versus surface water change. In other words, how many minutes of pumping did it take before we actually saw a connection between systems? And we can add up cumulative pumping versus surface water change. Now, for a minute, I'm just going to back away from this presentation, and instead, I'm going to open up a browser window, and I'm going to go to, first I'm going to refresh this because I will have to relog in, I believe. I'm going to go to our systems that are actually live in this environment. So if you can see you see my screen, what we're actually looking at here is the Wellntel Global Groundwater Center on a map with two sensors in it. And the sensor we're calling tank, which is the reservoir, is showing a distance to water in its last reading of 2.48 feet. That is from the top of the tank to where water exists in it. And the lab well hasn't shown a reading yet, and I'll show you why. It's actually because we haven't had a timed reading yet because we are in recovery right now. And the reason we're in recovery is that just a few minutes ago, I happened to turn on the pump and throw water into the tank, and now it's descending as that water heads into the well and is ascending. And so if we take a look at that pumping event itself, here it is starting, here it is stopping, and here we are moving into a recovery mode in direct opposition of the water that's filling inside the tank. I'm going to go ahead and just really quickly make this pump, start this pump one more time. You'll hear it go on. Set one. I think in the background you probably have some. You probably hear some noise. That is a pumping event that's been initiated, and in just a minute we're going to start to see these water levels begin to change. So the lab tank is on looks like it's on a 1-minute time interval. You can see 11:41:40 and then 11:42:40. So if I refresh this page right now, I probably ought to see the beginnings of new data. And here's my tank. There's 11:44:40, so it's not been affected yet by the increase in water level, but it will be shortly. Let me refresh that again. And I think we now have an uptick. And sure enough, there is water entering the surface water area. I'm going to turn the pump off now. And the reason I want to do that is I want to force a bundle of readings from the well system to the cloud to demonstrate the entire pump start stop event. So it'll take about 15 seconds while those readings are unloaded from the well system. I'll refresh this and see if it's started. Yeah, it has not begun yet. We had a timed reading. It'll be just a minute before those readings show up, and we'll see a pumping event happen. Now look here and see where we are. Refresh. Yeah, it is not in yet. But I can see the radio transmitting on the other side of the room, so we're going to give it another minute. All right, there we go. So here we are with the pump start and the pump stop that have been transmitted. And what I just did there in that start stop moment is I ran the pump for about a minute and 4 seconds specifically. Now I'd like to go one more level down with you and talk a little bit further about the data that might be useful in a program that includes systems like this. So the pumping event, in fact, the pumping event that I just did is not fully registered yet because we don't have recovery. But the prior one, which happened at 11 o'clock in preparation for this meeting, was a 6.6 minute long pumping event. And so that was the period of pumping that necessitated, resulted in about a 3.27 to about a foot, not quite a foot of drawdown. And here, of course, is our recovery period following that. So you can see that we're in a position to offer very detailed, very granular, and usefully dense data about local pumping conditions as it would relate to the connection between wells and surface water. So I'm going to go back to the slides for a moment. And I'm going to ask Joe to step in here and talk a little bit about the kinds of things we do with data like this in our lab, and then we'll push that out into the field.
Great, thanks, Nick.
Yep.
So what you guys are looking at here is basically a chart of a comparison between the data that Nick was just showing on the dashboard. The function of the tests that we do in the lab, both before and then live during this presentation, is to illustrate the value of having all of these data present on the dashboard, which can be quickly analyzed and it can be quickly downloaded as a CSV file and uploaded into some other sort of analysis tool or model. And this chart is an example of that, right? You're comparing the trends between the well, which is on the x-axis, and the surface water body, which is on the y-axis. And of course, in the lab scenario where you don't have a time delay or any sort of obstruction between recovery and fill, the connection is going to be very, very clean and very, very robust. But in other cases in the environment, you're going to have geological and hydrological impacts on water moving between surface water and groundwater, and it may take a significant amount of time for that connection to be apparent. And so having these data directly visible on the dashboard may allow for quick analysis and quick decision making, but being able to download it and quickly upload it into a modeling tool or statistical evaluation tool will allow for much more in-depth processing and analysis of the data that's collected with a Wellntel surface water groundwater system. And that can allow for connections and associations between surface water and groundwater to be found on much longer time periods or in areas that it may not be exactly visible. So that's the kind of the point here, right? Is to compare the lab example, which is a really clean, very robust case, simple case, and to the environment, which is going to be much more complex and it may be much more difficult to pull out those associations. But we provide all the tools that allow you to do that.
Super. Thanks, Joe. Let me go to the next slide. Want to talk a little bit about this as well? You want to tackle this one, Joe, or should I?
Sure, no problem. Yep, great. Sorry, I get noise going on in the background, so I muted. Okay, so what you guys are looking at here is a direct comparison between a Wellntel well system and standard pressure transducer technology. This was a USGS pump test that was conducted here in Wisconsin at a site that was looking to draw water from in high quantities from a deep aquifer. And so this pump test was performed to evaluate several management questions around that. And we were lucky enough to take advantage of that opportunity to both test and compare Wellntel technology against standard pressure transducer technology, which is used to measure water levels in wells as well. And so without touching water, the comparison that you're seeing here, the red line is the Wellntel sensor output, and the light blue line is the USGS pressure transducer technology, and the two match up extremely, extremely close. throughout the course of the test, which you can see takes place over um, almost a week, I believe, um, we were within an inch of that pressure transducer technology throughout that time frame, and the little kind of inset box that zooms in later on in that pumping test kind of highlights the comparison between the two and the accuracy comparison. The one note to include here is that both instruments showed a daily cycle and water level, small, about a tenth of a foot or so, plus or minus, throughout the duration of the test. And the Wellntel device showed that cycle was maybe a little tiny bit more dramatic than the pressure transducer showed. And that was something that was a valuable finding through this test, because we were able to determine that the way in which we were compensating for temperature in this particular location was a little bit too much. It was overcompensating just a tiny bit, and therefore caused a slight variation in the output. But when temperature was very uniform or very close, you can see in that inset that the two instruments were basically providing exactly the same measurement throughout that test. And so this is just a demonstration of kind of, again, contributing to the background information about Wellntel, comparison between a Wellntel sensor and a pressure transducer, but highlighting the value that's there in that we are non-invasive and don't touch water at the same time.
Super. So one more quick slide, and then we've got room for questions. Field applications, I think we've alluded to it already, introduce external factors that are unlike the lab test that you just witnessed. So unlike this lab test, you would have to expect to see declines in surface water instead of increases in surface water, since the reservoir, since we're assuming that in most field conditions, the reservoir is not receiving water from pumping. It, in fact, is hydrologically connected to groundwater below it instead. And of course, depending on distance and depth and geology and permeability and precipitation, correlations will be much weaker than what we've just shown in our analysis of this idealized system. But the opportunity is in the data density. What I mean by that is to say, remember that these are both systems that can be set up on 1-minute time intervals, and that the data from the well system can be meta-tagged with pump influenced information so that can be excluded or included. And so the more information that's available between these two sensor systems, the more likely you will be, given time and attention to it, to be able to either confirm a connection between systems or not. And that really is the key here. Here is an economic game changer in terms of being able to understand natural systems that we're really excited to be sharing with you.